So here we are in the part 3 stoichiometry, intro to stoichiometry notes video. We have went over the steps for solving stoichiometry problems. We look at what mole ratios are as well. And we looked at a compositional stoichiometry problem. We're now going to take a look at at reaction stoichiometry problems where the mole ratio comes from the coefficients in the balance equation. So this problem says, how many moles of oxygen do you need to react with 0.798 moles of H2 in the reaction that's given? This is a synthesis of water from molecular hydrogen and molecular oxygen. So we read the problem, identify our given and find. So in this case, we're given 0.798 moles of H2. A lot of times students just focus on the number. You also have to focus on the units and the substance here because that's what stoichiometry is all about, converting to and from different substances. So you need all of that. And we're asked to find, in this case, moles of O2. So since we're going from moles of our given substance to the moles of what we're asked to find, this is why it's called a mole-to-mole conversion factor. We're converting from moles of one thing to moles of something else. Okay, so let's take a look at this problem here. In order to map this out, we'll take a look at our steps. Our first step says if the given is not in moles, use the mole map. Well, guess what? Our given is in moles, so we can skip step 1 and go straight to step 2. All right, so we only use step 1 if we're given something that's not in moles. And then step 2 says convert moles of given to moles of find using dimensional analysis. Perfect. So I'm going to go from 0.798 moles of H2. Notice how I'm just not writing 0.798. I'm writing moles, and I'm also writing H2. You need to include all of that to moles of O2. That's what I'm asked to find. So that means I can stop at step 2. I don't need to do step 3 because my find is also in moles. So this makes this work pretty easy. That means this is really only one step. So now that I've done that, what I'm going to do is I'm going to set up a dimensional analysis problem, right? We're using dimensional analysis for this step. So what does that look like? We're going to take our given 0.798 moles of H2, and then we're putting it over 1 just to make it a fraction. Now in this second fraction is my conversion factor. That's going to come from the mole ratio. So let's take a look at the mole ratios. Where do I get that from? Remember, for reaction stoichiometry, you get the mole ratios from the coefficients in the balanced chemical equation. So let's take a look at the chemical equation here. I need to focus on H2, my given, and O2, what I'm asked to find. So I'm just looking at these coefficients. The coefficient in front of H2 is 2, so that's the number of moles of H2 in my mole ratio. And the coefficient in front of oxygen is 1, so my mole ratio for oxygen is 1 moles. So my mole ratio here, I'm just going to write it on the top, is 2 moles H2 and it's equivalent to 1 mole of O2. All right. So now the question is, well, where does this information go? Okay, where do I put this information? So I'm going to take this equation and turn it into this fraction. What goes on the top? What goes on the bottom? Well, of course, I'm going to put the 2 moles of H2 on the bottom since that's my given and I want to cancel that out. And they need to be opposite to cancel. And then the 1 mole of O2 goes on top since that's what I'm asked to find. And then I can easily cancel those out. So my math here is pretty simple. All I'm going to do is take 0.798 times 1, which is just 0.798. And then in the denominator I have 1 times 2, which is just 2. So it's just 0.798 divided by 2. And when I do that math, I get 0.399 moles of O2. So that means for this problem, if I start off with 0.798 moles of H2 and I wanted to figure out, well, how much O2 do I need to do this reaction? I would need 0.399 moles of O2. Sort of like when you're cooking, you're trying to figure out how much of each ingredient that you need. Okay, last step, last problem. This is what's called a mass-to-mass problem, and you'll see why in a second. So if we read this problem, how many grams of H2, this is my find, do you need to make 5 grams of H2O? This is my given. So you see in this problem, we're finding grams of H2 and we're given grams of H2O. So it's a mass to mass, from mass of one thing to mass of something else. So since I am starting with, my given is not in moles, I'm going to have to do step 1, which is to convert it to moles. So let's go quickly write our map here. We're going to go from 5 grams of H2O to next step is moles of H2O. So the next step will be what we're asked to find, the moles of what we're asked to find, so moles of H2. And then finally to mass of H2. Okay? Now H2 and H2O are not the same substance, right? Water is not the same as hydrogen gas. Okay, so let's do our step 1 here. If we want to convert from mass to moles, we need to go to our mole map and figure out what's the right equation for that. And it's this one here. Mole equals mass over molar mass, right? So I want to find the mole of H2O, and I have the mass as 5 grams. And I know the molar mass, I got that before actually in this previous problem, 18.02 grams per mole. That's the molar mass, got that from the periodic table. And so I simply solved by dividing that out, and I get the moles of H2O to be 0.277 moles of H2O. Boom. Now we're on to step 2 here, from moles of H2O to moles of H2. So how do I solve that problem? Do I use the mole map? No, this is a conversion factor using the mole ratios. So I have to look in my balanced chemical equation and get the mole ratios from there. So I'm given H2O, so here's H2O, and I'm trying to find H2, here's H2, and I'm going to use their coefficients as their mole ratio. As you can see, it's a 2-to-2 mole ratio, which essentially is a 1-to-1 mole ratio. So actually, the math here, seeing that it's a 2-to-2 or 1-to-1, I know that the moles of H2 is actually going to be equivalent to the moles of H2O. I really don't need to do the math for this one, but I want to show you what the math looks like anyway. So remember for step 2, when we're doing a mole, we're converting from moles of the given to the moles of the find. We're going to take our given, 0.277 moles of it, and put it over 1, just to make it a fraction. There should be no units in the bottom, it's just 1 to make it a fraction. Now we're going to take the coefficients in the equation and figure out what goes on top, what goes on the bottom. So if I'm starting with, my given is H2O, so I'm going to start with the 2 moles of H2O, that goes in the bottom. And I'm trying to find moles of H2, so look here and I see it's 2 moles of H2. That coefficient is my moles, okay? And I go ahead and do the math here, and once I do that math, I'll be multiplying 0.277 by 2 and dividing that by 2, so you'll see that the math here will give you the same. So I have 0.277 moles of H2. And I just want to quickly cancel out those units so we can see that that's how dimension analysis works. All right, so that's all done. All right, so now my next step is to go from moles of H2 to the mass of H2, and I'm going to do that in my third step here. And once again, I'm going to use the mole map, the equation and the mole map that helps me to go from moles to mass, which is this equation here, mole equals mass over molar mass. Now in this case, I have the moles and I have the molar mass. I need to solve for the mass. So when I set this up, I'm going to take 0.277 moles of H2, and that's going to equal to the mass of H2, which is what I want to find, over the molar mass of H2, and I can use the periodic table to solve for that. So for the molar mass of H2, it's going to be 2.02 grams per mole. Okay? All right, so now how do I solve for this? In this case, I'm going to multiply, the math here is just to multiply these two together, so 2.02 times 0.277. And that gives me the mass of H2 to equal 0.55 grams, about. sorry, 0.556 grams. Okay, so the key thing here is for this problem, you have to first convert from the mass of your given to moles of given, and then from the moles of given to moles of fine using the mole ratios, and then from moles of fine to mass of fine using the mole map equations. So in the mass to mass, you have to do all 3 steps. But in the mole to mole problems, you only have to do the 2nd step, which is really nice. All right, I hope you found this video helpful. Have a quality day.